Hello and welcome to Digital Woodcarver, or not Digital Woodcarver, Digital Woodcarver, but Spindle TV. How are you guys and girls doing tonight? The last couple of weeks we have been working in the Aspire software, and speaking of Aspire software, last week's model, the grapevines and everything, those will be available in the description of last week's video this evening. I didn't get to them over this past week, getting them in there, so if you were looking for them, they'll be in there this evening after tonight's class. I didn't get them in there. I ended up getting sidetracked. But tonight we're going to be working in VCarve. VCarve Desktop, VCarve Pro, even Aspire, but everything that we're doing, we can do in all three of the programs. And we're basically going to look at some simple and straightforward layouts that we can do for doing things like clocks or what have you. And I'm using a clock as an example for the simple fact that I just finished modeling a clock for the Spindle TV training subscribers and everything. And I thought that file turned out really nice and thought, okay, let's do something along that realm, but in VCarve Pro. All right. Hello, Michael. How are you doing? And Kevin and everybody, Roger, Jim, welcome everybody. All right. So not going to make a long introduction. Basically, we're going to be working in VCarve. We're going to be working with the circular array tool. We're going to be looking at different design concepts, working with the different tools within VCarve, and see if we can come out with a pretty cool clock and everything. And if Sylvia Klosterman is in tonight's class, you can blame her for tonight's subject as far as we're going to do an owl clock because I got owls on the brain because I was helping her with a pendant, little owl pendant she was making for a necklace. And I thought, man, there's some pretty cool owl vectors out there. So we're going to play around with some owls tonight. All right, with that being said, let's go ahead and let's get into the topic, the subject matter. And let's see, that is going to be in camera number 2. There we go. And let's get me down in the bottom left. All right. So now what you see on the computer screen right now is just an example of a clock. Many years ago, I taught a class to the Digital Woodcarver owners on making a series of clocks. We made 4 clocks, and this was one of them. This was the American Pride clock. And if we were to look at the tool paths in this, just to give you a kind of an example, let's preview all the tool paths while we're talking. This is a very simple kind of a VCarve clock project. The clock kits and mechanisms and hardware and everything, was from a place like clockkit.com, KLOCKIT.com, clockkit.com. This is a simple mercury or quartz, mechanism that plugs into the back, and this was the front. And so when it was all colored and painted, it was a clock that looked like this on the screen. Something, pretty cool and simple. And just simply using end mills and V-bits. Well, it's not always all about modeling and stuff. Tonight we're going to make a clock and do some basic layout and all, and we're going to just use we're going to do a VCarve clock, so everybody will be able to do it, whether you're a beginner or you're advanced, and with very minimal tools. Now, of course, it's not necessarily about the clock project itself. It's about the approach and the design and the procedures and all. So hopefully you'll pick something up out of tonight's class that might be useful to you in the future. Now, before we get started, I promised a customer, Mike Smith, that I would explain to him why when we were doing modeling, in the Aspire software, when we were reducing the size of a model, and when you reduce the Z height of a model, you lose detail and stuff. He said, well, why wouldn't you be able to use the Emboss tool that you showed us a couple of classes before? And the Emboss tool is not really, when it comes to a low relief model, it doesn't allow for, and the software will pop up a warning saying that this model is not ideal for the Emboss tool. The Emboss tool is designed for a 3D model. If you guys and girls remember the Valkyrie and the skull and the ravens and everything we did a couple of classes back, where we took an actual three-dimensional model that was like 3D print model type thing, and we positioned it and orientated it to get a perspective of it, and we flattened it out using the Emboss tool to basically flatten this part out into a low relief while keeping all the surface detail and creating those two copies and overlaying one over the other, so we end up with a kind of a low relief model from that three-dimensional print type model. He said, well, if we can use the Emboss tool to do that, to retain the surface detail, wouldn't we be able to resize a model with the Emboss tool and still keep the surface detail? So let me just really quickly go into Aspire to answer that question, and then we're going to get into tonight's class. So I'm just going to create a generic project. I'm not sure what that was, but there was some kind of error in the software. Okay, so in the software here, I'm going to open up just a low relief model. So let's go into our clip art, and let's grab really anything. Just going to grab this alligator for a moment. Okay, so if we look at the 3D view here on this alligator, this is already set up for a low relief. There are no undercut areas that are kind of extruded out. If you remember when we imported those 3D model types, we had all of that underlying meat there that we had to kind of get rid of. We had to shrink everything down, and that was the Emboss tool that did that. And it shrunk and got rid of all of that stuff while it retained the surface detail. Well, there's none of that in this low relief alligator model. I mean, it is designed already as a low relief. Now, currently, this model has a shape height of 1.2397 inches. So a little over an inch, and a little under an inch and a quarter. Let's say that I wanted to size this down to a 3/4 inch board. Well, with the regular size tool, I would come in here and I would type in, 0.75, and I would reduce that Z height of that model. Now, when that Z height reduces, because it is bringing down that model, it's also reducing the shape height too, and we could sacrifice some detail. So if we look at before and after, we have some, a little bit of loss, not much. There wasn't a whole much of reduction there, but a little bit of loss in that, in the detail a bit, around the mouth area and things like that. Things just got smaller, right? Well, let's undo that, and let's look at the Emboss tool, and we're going to get this warning on the software. It says the selected component may not be suitable for embossing. Basically, the embossing tool is intended for use with imported components or 3D models, and works best with high rather than low relief models. So it's for those models that when you import that three-dimensional model in, it's really high and it's got all that underlying meat underneath it. When you use the Emboss tool, it drops it down, and it drops it down, and it still retains, as it's getting rid of all that stuff underneath and brings it down to a low relief or a low level, it's retaining the surface detail to the best of its ability. Since none of those elements and artifacts and everything apply in this low relief model, this is not the best tool for it. And so therefore, I can still open the Emboss tool and everything, but when I go to reduce the size here, you can see that it's basically just flattened that model out like a pancake and everything, and it's trying to retain that surface detail. Now, of course, I would want to, let's say I scale this down to, let's go 50% of what it is, what it was and everything. It's going to reduce the model down, but it's trying to keep the shape heights peaked up, right? It's trying to keep those shape heights peaked up. That's what the Emboss tool does. It's trying to flatten down everything else around it, but keeping the peak heights up. And therefore, you know, we tried to reduce this model 50% its normal size, and all of the peak heights kind of remain as they are, if you see here. Now, if I go and say, okay, let's try to bring those down some, and let's bring this down, you know, like we would with the Emboss tool, we'd come down to about 1% in everything, then there's nothing there. So, okay, let's go back up to, let's go 25%. You know, it's getting rid of all the stuff underneath, and it's going to try to lower the peaks as much as possible, but there's not enough underlying material to do so, and therefore it's not the ideal tool, right? When we, let's hit cancel on this to get back to normal. When we are trying to resize this model, we're trying to maintain the overall shape and the curves and the contours and everything. Let's bring this down to 0.625 and click apply. We're trying to maintain the curves and contours and everything and still keep all of the, you know, the shapes kind of intact. The Emboss tool doesn't do that. The Emboss tool tries to keep, you know, while it lowers everything else down, it tries to keep all the shape heights and the peaks and everything up high, so that they can be smoothed out to that 1%, 5%, whatever it may be. So Mike, if you're in tonight's class, that's why I did not use the Emboss tool when reducing the Z height of a model, because it was already a low relief model and there were no underlying artifacts where the Emboss tool would be effective. Okay, so hopefully that answered that question so we can get back on track. I just wanted to take a minute. Thanks for indulging me with that. But I told him I would answer that question and everything. All right, so the Emboss tool really is ideally for models that are higher, that have those underlying artifacts, so it can reduce those and keep the pink heights and everything and up and all. All right, so Mike, I hope that answered your question, or kind of at least kind of demonstrated somewhat why it wasn't the appropriate tool. But you know, it has its place, and unfortunately what we were trying to do last week with, I think we were reducing the height of the grapes with, or the height of the leaf. We were trying to reduce everything without losing the leaf detail and stuff in that grapevine, and the Emboss tool would not have been effective for that. Okay, cool. All right, now coming back to our clock here, again, this is just an example of a simple VCarve clock. And everything, just a kind of an American Pride clock with a little bit of color and stuff. Well, what we're going to do, we're going to start off with a new project. So I'm going to close out of this one, and I'm going to create a new file. I'd like the diameter of this clock to be around 16 to 18 inches. So I am going to go with a 24 inch by 24 inch project, with a 3/4 inch, 0.75 thickness. So I just make it out of a nice 3/4 inch board. We'll touch off on the material surface, and I'm going to set it to start at the, we'll start in the center there, and we'll click OK. All right, now The first thing that I want to do is go ahead and I usually kind of get the clock body laid out and the numbers and things. So let's go ahead and start off with a simple circle. And I'm going to go with, this is 20 inches. I'm going to go with an 18-inch diameter clock body here. And now I need to get my numbers in, whether they're Roman numerals or they're regular numbers, Arabic numbers, whatever the case may be. They could be just lines and dashes, whatever you want it to be. We're going to create them in. And what I'm going to do is I'm going to come in here with a line tool, and right up at the top, I'm going to make a dash. And I'm going to hit space. And on that line, I want to copy it around the clock 12 times for the 12 hands of the clock. I'm going to use the circular array tool for that. And my rotation center is going to be the center of my material. In this case, it'll be 0, 0. I want to go 12 times around 360 degrees, and I want to create those 12 hands. Now, the reason why I'm using the lines versus like numbers and all is because every line, every single line, if I go into node editing, and we focus it on line here, we have a start point, an end point, and a mid point of the line. And that midpoint is going to be a key factor for me. It's going to help me snap my numbers, my Roman numerals, my shapes. It could be all stars. It could be whatever you want for the, the numbers of your clock, whatever, design you want it to be. I want this center point of this line so I have something to snap to. Okay. So in this case, I'm going to go ahead and come in here and create a new layer, and I'm going to call this layer my number layer. Okay, and on that number layer, I'm going to just lay out some numbers. We'll pick, whatever font is appropriate, and let's just do it over here to the side. And I'm just going to literally 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, 7, 8, 9, 10, 11, and 12. All in one big long text block. Okay. I'd like those numbers to be about 1 inch in height. And now I can come in and right click on those numbers and break that text block into individual lines. Break text block into lines. So now each one of the numbers are all separate. Okay. Now I'm going to take, back in my layer 1 here, I'm going to take my circle and my lines here, and I'm going to group those together. And even though I group them together, I should still be able to snap the center of my number to the center of my line, because that node still exists. So if I went into node editing mode on this here, let me get out of node editing mode. The center of my number, which is represented by that little square dot right there, is snapped to the center of my line, which again is represented by that little dot there. So even though that everything is grouped together, I can still work with that. Now I'm going to undo a couple of things, because I would like to increase my letter size or my number size to 1 1/4, 1.25. There we go, just a little bit bigger. And then again, I'm going to break it into text lines. Okay, let's go ahead and group all that together. And so I should have my grouped little circle for my clock. And then I should have my numbers, which I need to move them back to the proper layer. So I have 2 separate layers here, 1 and 2. Okay, so starting off with number 1, I'm going to double click on it and I'm going to grab it right in the center. So I'm going to put my mouse right over that center box and I'm going to hold down the left mouse button and I'm going to grab it in the center so that I can snap to the center of that line, right? And that's not where the number 1 mark goes. I know, ladies and gentlemen, that's where the number 12 mark goes, right? So we're going to do the 12, but that's what I want to do. So on the number 12, we're going to grab it in the center and snap it right to that center line. Okay? Now, if I come over here and try to snap the 1 here, well, now I've got to try to rotate the 1 or what have you, so everything looks, you know, like a clock, you know, symmetrical. Or I could decide to keep my 1 vertical, my numbers vertical all the way around, which I don't like. I like the numbers to have that angle that they're at in things. But you might like to have your numbers just vertical, upright. And that's totally up to you. It all depends on, you know, what you want and all that good jazz. Now, I like the numbers to be angled based on the line. The only numbers that I kind of either keep vertical would be the 3 and the 9, or yeah, just pretty much the 3 and the 9, and then of course the 12 and the 6. Those will stay vertical. I want the other numbers to be angled and everything. So let's undo those 2. And what I want to do now is I want to select everything on the clock, including the number 12, and I want to be able to rotate this by the exact degree to get the next line to move up into this vertical position. So I'm going to go to my rotate tool and I'm going to relatively rotate. I'm going to go 360 degrees divided by 12 equals 30 degrees, right? So now every time I click apply, it's going to rotate that 30-degree increment for each of my lines to be vertical, right? So I'll go ahead and rotate that one, and now I can take my 1 and snap it to there, select everything, click my rotate again, grab the number 2, snap it to there, select everything, apply, working my way around. Now when it comes to the 3, I may want the 3 and the 9 to be vertical, you know, versus sideways and stuff. So I'm just going to hit the number 9 key on my keyboard and I'm going to turn that. It might look weird to y'all when the clock is all said and done, but again, it's whatever preference it is for you. So again, I'm going to select everything and then just literally work our way around and snapping our numbers in. And you got to select everything to do your rotate. So all the numbers and everything rotate appropriately coming around, you know, as we go around and stuff. The 6 is going to be upside down. So let me take that 6 and rotate it like that. Yeah. All right. And just keep clicking apply on the rotate tool. I'm keeping the rotate tool open while I do all of this. And again, the number 9, I'm going to have it vertical. Rotate around, snap the 10 there, and finally rotate it one final time to get the 11. Okay, and then I will rotate it one final time to get my clock back the way it was. Okay, all right, cool. So now at that point, now that I have those numbers and dials and everything, I don't really need the lines anymore and all. Now, what I'm going to do is I'm going to ungroup those lines and dashes and everything, and I'm just going to hold the shift key down and select this here, and with those dashes I will, instead of deleting them in case I need them again in a moment or in the future or whatever, I'm just going to take the remaining selecting items and move them to a new layer, and I'm just going to call it my layout lines. We'll call it, let's give it a little more specific, number layout lines. And I'm going to turn the visibility off and click OK. So that hides them, right? So now we have our clock hands and everything, or our clock numbers in the exact place and kind of orientation is to where we want them. All right, so now that I have the clock and everything laid out, I'm going to go ahead and move it down to the bottom of the board because I'd like to put something up here. Now, my clock is 18 inches in diameter. I may reduce that down in size to get more area here, but I believe I have enough room, 6 inches, to do like a little 6-inch item up here. Whatever it may be. And we want, of course, we want it to look perspectively correct. But what I am going to do before I do anything is I'm going to create a second boundary around my circle so I have a border. So I'm going to actually drag the circle up just a little bit, and I'm going to, on that circle, I'm going to create an offset boundary on the outside, and I want a border around my clock of 3/8 of an inch. Okay, kind of like just a little bezel, if you will. And now I'm going to take all of that and just move it down here. Now that leaves my upper area, and of course I can, if I don't have enough room, I'm still going to draw everything, and if I have to, I'll rotate the clock 90 degrees and I'll do it on the longer board because 24 inches is the maximum area of my cutting area on my y-axis. So I can't go any more this way, but I can go a lot more on the X. So once I get everything drawn, I could still rotate everything and just cut it out of a 24-inch wide by 30-inch board or something if I need that extra room. So I'm not really sweating that too much. But I'd like to put something up here. So this is going to be a wall hanging clock, and I'd like to have some kind of design up here sitting on the clock. Maybe an owl perched up on the clock, right? Great. Harvey, I'm glad you think it's a good tip. It's great when you're laying out things like this. Think of like a compass, right? Let's say you were doing a compass rose or something and you wanted to put the degrees on and you needed to rotate for the number of the degrees. You could take 360 and divide it by, 4 to get your north, east, south, west. Then you could divide it by, 360 so you can get your little dashes all the way around. Whatever the case may be, to get your little 1 degree, half degree, 2 degrees, 15 degrees, if you want to mark every 15 degrees. So compasses, clocks, anything like that where there's a circular pattern, it works very well, right? Okay, so let's import an image. And, when it comes to this clock, I could create a model. I could create whatever I want. I could put a model there, but I wanted this to all be a VCarve. So I'm going to bring in an item, an image that we're going to trace, and we're going to VCarve it, and then we're going to create a boundary around everything so that we get this nice looking clock with this cool V-carved animal or whatever we want at the top. Just to give you, while I'm here, I'm going to open up. There's two that really kind of tickle me a little bit. We're going to open up this one first, and we'll move him to the side for a minute. And let's grab this one. I like him. He's pretty cool looking. And finally, we'll grab another one, because we may want one where we have kind of spread wings, right? Sitting on that clock like that, you know, something like that. The eyes on this one throw me off a bit. Looks a little demonic, but you know, there's all kinds of examples. We'll throw that over there and we'll set it to the side. But you know, I'm thinking something along the effect where we have a little either this one or this guy here with the googly eyes, you know, when we size him up and everything sitting on top of the clock. Kind of like that one. We're going to kind of play around with that one, but just some fun stuff, right? So this is all just all fun and games. Let's go ahead first of all and let's trace this image. And let's zoom into it so we can see what's going on here. And I'm going to bring this up to about... I think 50 is going to be good. Let me, if my eyes aren't deceiving me, 50... 75 is a little dark around the eyes. Let me back it up a bit. Yeah, I'm going to go with 50 on this one. I'll turn the noise filter up to 4 and preview. Apply and close. All right. So on this, I just wanted a good bit of detail, and bear with me a second. Yeah, he's got those big black googly eyes. All right, so I'm going to just delete the image. Normally, we would just come in here and turn the bitmap layer off. But I'm going to leave I deleted the image because I'm going to leave the bitmap layer on because I have these other two images. I might like one versus the other. Just some fun stuff. All that wonderful jazz. All right, let's go ahead and zoom back into him for a minute. And first thing I'm going to do is I'm going to ungroup this image, and I'm going to delete these vectors here, and I'm going to select here, and now I'm going to size this up, and stand by. I think I confused my computer for a second. There we go. All right, let's try that again. Size him up. Now I can already tell right now for the size that I want the owl, I'm gonna definitely have to make it on a much bigger board, because it's either that or I'm gonna have to make the clock smaller, right? It's either I got to sacrifice one or the other. It may look proportionally better if I resize the clock versus the owl, but I'm not sure. Let's undo this for a minute. Let's resize this down to, let's go with a 16-inch diameter clock. There we go. And then we'll set this up here. And I want his feet or his claws sitting on the top of this rim. So that means that these vectors in here, I'm either going to, if I want to keep the tail, it wouldn't be realistic, right? Because the tail would be behind the clock normally. So we will end up recreating and getting rid of these vectors and closing off, so it's just this owl sitting there, and we wouldn't have those tail feathers. You know, show me how you shake your tail feathers. Okay, so we'll get rid of those in a minute, and we'll end up closing off the vectors and stuff. And I'll show you how we'll do that in just here right now. That's our next step. So what I'm going to do is I'm going to take the outside bezel ring here, and I'm going to go in, and really it's going to be kind of part of this outer ring, you know, one whole item. I could come in and select all of these vectors that are down here, including the outside perimeter. and I could group them together as one item, hold down the shift key and select that outer ring, and I could come in here and trim with the trim tool and clear everything inside that boundary away, right? So as it processes, it will close off those vectors and trim everything to, you know, that bezel, right? So just kind of redraw that. I'm going to undo that for a minute because that's what I want to do, but I want to do it not right on this bezel. I want to have a little bit of a gap space in between these two. So I'm going to offset that outside ring outward just a small amount, literally probably about 10 or 20 thousandths outward. And that's going to be the line that I'm going to clear to. So we'll select all of those vectors. Oh, those are grouped together. Let me ungroup everything. Bear with me a minute. Okay, let's grab all of that, including this outside vector. And also, don't forget to turn off the number 12. We're going to group those items together. We're going to grab this outside circle and we're going to trim the regular trim tool, clearing inside the boundary, and the outside circle will be that boundary. Okay. Now, once we've done that, I can go ahead and delete that outer ring. I'm just using that to kind of create a little gappage between here. And you may want to come in and draw the claws where they're, you know, hanging over this bezel, however you want, whatever looks appropriate to you, right? Those kind of things. And so now I have this cute little owl here sitting on this clock. Let's go ahead and size it, get it down a little further. And just for class purposes, I'm going to change my board size on the height to 30 inches just to get everything on the whiteboard to make it easier to view. But I will end up, because I don't have 30 inches on my CNC, I will end up rotating the part 90 degrees to cut. Okay. Yes, Sam, trim is a lot more efficient than scissors in a lot of cases where you're clearing inside of a particular boundary or outside, because one, you don't have to click, 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 click everywhere you want to trim. And number two, you know, it's going to close those vectors up appropriately so you can VCarve or whatever the case may be. Right? All right, cool. Now, on the object here right now as it goes, if I were to select all of this, and what I always do before I get too far into the design is, number one, save your work, right? Let's go ahead and save. File, save as. And I'm just going to call this my owl clock. Okay. And first thing I like to do is I like to select everything, and I do a generic VCarve toolpath that's going to end up getting deleted. It's not going to be used for anything. It's simply going to be used to show me what this would look like as it is right now as a VCarve, right? So I'm going to create a VCarve toolpath. I'm not going to put any flat depth in this one or any flat area clearance tools. I want to look forward to see if the software is going to warn me that I'm cutting through my material, or I also want to look for, if I'm not getting a warning, I want to look and see how deep things are carving, right? So I want to go ahead and calculate this toolpath. And I do have some overlying vectors, overlaps and stuff, so it's telling me that. Instead of clicking continue anyway, I want to see what those are. So I'm going to go ahead and go to the vector validator, and I'm going to click search selected. And I only have one little area right here, and it's a pixel. So if you ever see these little figure eights or these square pixels here, those are trash. They're pixels. And so I'm just going to go ahead and delete those. And to eliminate those, there's another one right there. To eliminate those in the future, I had when I traced the image, I had the noise filter turned up to 3. I'll probably turn it up to 4 or 5, maybe even 6, to ignore those little pixeled areas, because all of these square pixels are trash. And some of those square pixels could be overlapping and things like that. But I'm not going to stress it too much. I'll just go ahead and go through the ones that I can visibly see. There's 2 right there. Up here, there's a whole gallery of them, so we'll get rid of that. So all these square pixels are pretty much trash. We'll get rid of them. Okay, let's get rid of this big gallery, not the teardrop. Delete that, and these 2 down here, and I'm going to call that good for right now. So let's do that one more time. Let's close the vector validator because that we got rid of the problem, and let's calculate that toolpath. Now what I'm looking for is, am I going to get any kind of warning that I'm cutting through the material? No warning popped up, so great. And if I preview the visible toolpath, that's a pretty cool looking owl, right? Goofy looking little owl, right? So I've got this owl clock, and I'm going to be happy with it, you know, for what it is. Now, of course, I want to make sure that my clock body is at a size that when I buy the mechanism, you know, usually it comes with clock hands. I want to see, like if I go to clockkit.com, I want to see what, you know, how long the hands are and everything. And if I need longer hands or shorter hands, they have individual where you can buy, oh, I have the hiccups now. Sorry, guys and girls, where you can buy individual parts and stuff. But on a 16-inch diameter clock, a standard clock kit would be fine. I do want to go ahead while I'm here, and I do want to go ahead and put in it's going to be a 5/8, so 0.625. That's not the true for all clocks and all, but I do want to put in the center dot. And if I click on one of these circles, my dot should have snapped right to the center of that circle. Because when I had the circle tool open, I took the mouse and I typed in my 0.625, and I dragged the mouse over, and what I'm looking for on the little crosshair is when I find the center point, there'll be a little black dot in the center of that crosshair, and it's showing me that I'm at the center of that particular point. So I can go ahead and click that dot there, and I can validate it by clicking this outside one, and I can see that on that outside ring, that is in fact the center. It is very helpful if you have your smart snapping and geometry snapping on at all times, because that allows you to snap to these different points. Okay? Cool. And so I've got this pretty cool clock here. Now, when this carves out this profile cut here, I need this profile cut that's going to cut out this owl and everything to kind of coincide with, you know, my outside ring, if that's going to be my outside bezel. Otherwise, I want to make sure that I have kind of a raised effect. Now, this is just a very simple VCarve, right? I would like to give a little bit of dimension to this project. I would like to have the numbers raised up slightly, but I also would like to have the owl raised up slightly to kind of give it a three-dimensional illusion. So what I'm going to do is I'm going to put another boundary around the entire clock so I can get that raised effect on everything. So it's basically going to cut out a little channel, if you will, around everything. So let's go ahead, and I'm going to select this as well as the outside boundary of the owl. So those two boundaries there. And I'm going to offset them outward whatever distance I want. In this case, I'm probably going to maybe go about either a 1/4 inch or 3/8. I'll look and see which one looks best when I create the offset. I think I'm going to stick with a 1/4 inch. That'll be good. A 1/4 inch. Now, here's the kicker though. I've just created an outside boundary around this owl. So if I were to V-carve this right now, let me turn off that middle circle. If I were to V-carve this right now, the owl is not going to look as good as it did a moment ago before I put that boundary in. So I'm going to turn off the flat depth. I'm going to calculate this tool path. I'm going to let it calculate. And I'm going to get a warning about cutting through my material. It's going to take 10 inches to cut, right? Because of the numbers and everything. That's a big hole right there. So I have to have a flat depth. So let's go with I'm going to go with a 1/4 inch. No, I'm going to go with 1/8 inch. Too many decimals. 1/8 inch. And I'm going to calculate that again. So that way this inside area will get pocketed out and the numbers are going to be raised up by 1/8 inch. Okay, so if we reset this and we preview the visible toolpath, my clock body is going to look okay. And hold on, let me stop that. That was inefficient all the way around. I need to add some clearance tools in here. So I'm going to add in a 1/4 inch end mill as well as 1/8 inch end mill. You don't have to do two. Since I have two, I'm going to do two, and I'm going to recalculate that. That was insufficient having that V-bit trying to flatten all that stuff out. All right, let's reset that and preview the visible toolpath again. Now this time when it carves, the clock body is going to look okay with the little raised numbers and everything, but the owl is not going to be too desirable in my opinion. So the eyes are backwards and all of that stuff. That's not what I want. But I do like the fact that I get the raised numbers, right, on the clock and everything. So since I created the outside boundary around that owl, I need to create another outside boundary on just the owl itself so that I get that extra border around, right? I get that extra border around. And I just want to do it around the owl because I want the clock carving just like it is. So on this outside owl, I'm going to offset another line outward. And in this case, I'm just going to go a small amount. Let's see, I went 1/4 on the big one. So let's go 1/16 inch. Too many decimal points. Okay. Just to create that extra outside boundary there. Now on that outside boundary, I've got this little overlap happening right here. Okay. So I need to clear that overlap and I'm going to clear it just to this boundary right here. And I'm going to sacrifice 10/1000ths of an inch on this boundary, or 20/1000ths. So I'm going to select this overlap that I have. I'm going to select this inside boundary and I'm going to use the trim tool again and trim clearing inside the boundary. And then on that inside circle there, I'm going to just offset it inward the 20/1000ths of an inch space that I want. 0.02. Oh, let's get a decimal in there. And I'm going to delete the original when I create that. So I still want that gap in between, so I had to sacrifice that 20/1000ths of an inch. Now, when I come in here and select everything, and I calculate that toolpath, I'll get both effects that I want. I'll get my clock with the raised numbers, and I'll get the owl that has a nice outline around him, but he'll still have that cool looking V-carve where his eyes and all are pretty cool and all that stuff when I paint him and all. All right, so we get that Cool effect, right? Nice. And so I get that nice bezel ring around the clock. I get the raised numbers and everything. This center hole will be drilled out for my quartz, so I'm not worried about that right now. But I get that nice looking clock. Now I got to do the profile cut, and I can cut everything out to my final shape. So on my final shape, I got that, and I've got that kind of raised effect. It's only an 1/8 inch deep, you know, but still I get that channel. Let me zoom into that. I get that channel around that owl a bit. It just gives it just a little bit of definition. Let's turn the color off so you can see. So it's just that outside channel, even though it's an 1/8 inch deep. I could have went a 1/4 inch deep, right? You know, on that, but I don't want my numbers too high and everything. So, but I just get that, all I'm doing is I'm getting just that nice little channel around here to kind of just give it a little bit more definition so it's not so flat, right? Just to give it a little bit of a kind of a small raised effect. Now we're going to go ahead and on this outside here, I'm going to offset it outward another 1/4 of an inch. Let's go 1/8 of an inch. Either 1/8 or 3/16. 1/4 was just a little much for me. There we go. And now I'm going to, on that vector, I'm going to do my profile cut, cutting all the way through the material with my 1/4 inch end mill. Calculate that toolpath. Preview that toolpath. I don't have any tabs or anything in there right now. And, you know, let's add some color back in there. Whatever color that, you know, it plans to be. I kind of like black for the owl. Probably black on the eyes. I would probably paint this in multiple different colors and all. Maybe a little brownish black in the body and all. And then in here, I'd probably leave that bare or something. Now inside here, if I wanted to, I could add some texture. I could add some text. You know, instead of a cuckoo clock, it could be a hoo-hoo clock. That's my dad joke for the day. I don't even know if that even classifies as a dad joke. A hoo-hoo clock, a woot-woot clock. Something like that. But just some, you know, just something, you know, a little bit different, right? So there's a quick and simple kind of clock with a cool little, you know, cool little something on there. Whatever, you know, whatever you want to make of it. We could have done the owl with the spread out wings. It could be an eagle sitting on top of there. It could be whatever you want it to be, right? So let's go ahead and save those changes. Thanks for the reminder. Now let's take a minute here while we're at this phase right here. And again, like you can thank Sylvia Klosterman for the owls, because I got stuck on owls and I thought that was a cute owl. And I've been working with her owls this past week with her. And ever since then, I've had this infatuation with owls. I don't know why. But let's answer a couple of quick questions. Let's see here. Good basic stuff that we all forgot. Thanks. Good. Awesome. You could do separate boundaries and dome the owl or dome or bowl the clock face, then angle the numbers. Right. So what Suicide at All Times is referencing to, we are in VCarve Pro. So we are not in Aspire Like to Create a Model. So we would use, if we wanted to dome to give, if we wanted to give something a little bit more curvature and everything to it, that carve, because we can have a VCarve follow the curve of a model. We could go into our clip art tool, and in the clip art we could go under domes and dishes. And let's see here, 30-degree dome. And we could size that dome up so that it kind of, you know, the owl falls in that nice curve. You know, we don't get into the shallow areas and everything. So we're kind of right in the center of that curve. And when we create that model, depending on, let's go to our properties of that component. Right now it's about almost an inch thick. If we look here, you know, so it's got about an inch in height. Let's reduce that height a little bit. I'm going to go ½ inch. I can go 0.625. And let that reshape down to size. And then everything on that dome, I want to get rid of, I just want the owl to be domed. So I could come in here and on the boundary that's around the owl, I could use that as a clipping tool path. So I could select that vector there, and I could come into the level and I could turn clipping on and apply that to get rid of everything else from around that model, so that we just have kind of that owl shape. And then on the owl tool path, if we just did the owl by itself, because we could separate its tool paths. Let's see, I want to turn this off. And I could do a simple VCarve tool path on that. Oh, let's set that model height to 0.625. It didn't do it earlier for some reason. Click close, put that at the top, click OK. On that VCarve tool path for the owl, I could do no flat depth on this one, no there, but I do want to project it onto the 3D model. So that way when it carves, if we were to reset the preview, let's select this boundary right here. We got to create our 3D finish. I'll do a finish cut instead of a rough and a finish, just for review purposes. Let me see what size my tool is. 1/8 inch is fine. Let's calculate that tool path. And preview that visible tool path. Turn the color off, and our owl, when it's all said and done, and when we cut it out, it would actually have a curvature to it, which you can't see because it's inside of everything right now, but it would have kind of a curvature to the body, you know, just a small curve. So that's what Suicide All Time is talking about. We could, you know, we could dome the face of the clock if we wanted to. We could dome the owl and give it a little bit more body that way. And then with the help of clipping in the VCarve software, we can get rid of everything around that dome. So just our owl body has that curvature, right? That kind of thing. So that's what his comment was referring to. You could do separate boundaries and dome the owl, or dome the bowl face and angle the numbers and things. So that's what he's kind of referring to there. Let's see here. For all of us kids who don't think the math class in school mattered, it does. Think through the project. Absolutely. Math class is important. Rodney says, I noticed you didn't do a double-sided cut. I always recess the clockwork into the back. Yes, we would do a two-sided project, and we would pocket out the back of the clock so that our little quartz mechanism would be recessed in. I just didn't set it up as a two-sided project because I'm not really focusing on the back right now, but we'll change it in a minute Right now, we're just creating some various designs, Rodney. And but yes, you're at 100% correct. This would be technically a two-sided project because we would want to flip the board over and carve out maybe a keyhole for hanging on the wall, as well as the pocket for the quartz piece to fit in, and all that stuff. So that way it's not just flush against the back of that three-quarter board. We want it recessed some and everything. And mostly the shafts on those quartz clocks are shallow anyway, so we do need it to be able to poke through so we can put the hands on the front. So you're 100% correct there. I just haven't done that because we're kind of focusing on the design aspect of the thing right now. But when it's all said and done, before we get to the end of tonight's class, it will be a two-sided project. And it probably would have been smarter for me to set it up as a two-sided project to begin with, but I'm kind of focusing on the front side right now. So, but all that, you're 100% correct, Rodney. And let's see here. And thank you, Sylvia. Elena did a Mousing Owl 3D training class and all that good stuff. Yeah, so we created some owls and all for her little necklace pendants and stuff. But so yes, we could, if we wanted to dome this out. And it's unfortunate you can't see the dome right now because all the other wood material is around it and stuff. Here, let's do this. My model height is 0.625. But my dome height is, my shape height is not that high. Bear with me a minute. Let me find a low spot on my owl here. 0.0868. We'll go with that number for right now. Let me just really quickly do a rectangle around the perimeter of the board. And I'm going to select that rectangle perimeter. I'm going to select this vector right here, and I'm going to do a pocket cut, cutting down to 0.0868, I believe it was. Calculate that toolpath. Preview the visible toolpath. Let's just mill away that top layer for a minute. Okay, I didn't go down deep enough. Let me go a little bit deeper because I need to get the head, where the head is. It domes around. Here, wait, the profile cut might take care of that. Let's see here. Profile the visible toolpath. Or preview the visible toolpath. Yeah, no, he's still kind of recessed in. Let me take that pocket down a little bit further. This will probably look weird. Preview the visible toolpath. This will look weird because it's not actually set up for this, but I just want to kind of demonstrate this. So I still didn't get down far enough on that 1/8 of an inch for the ears and everything. But if we look, let's see here if I can tilt it to the side a bit. It's hard to see. My little dome's not high enough, but there is a little bit of curvature, you know, to that and stuff. Let's fill in with some color here. Ooh, a little bit too much black. Let me go with a lighter color, gray. There we go. So you can see how cute that little owl is. Right. All right, so anyway, that would be something to play around with. Now I'm going to take the dome out of the equation because I don't want to dome him up. But that's how you would do it in VCarve if you want to give something a dome or a dish, right? Cool. Let's see here. Two-sided and a 90-degree rotation. Yes, two-sided and a 90-degree rotation. And the purpose for the 90-degree rotation is because actually that's how I have to cut it out of my table, because it's got to be along the length of this, you know, the height, because it's tall. It's got to be cut out of my x-axis. So I got to rotate it 90 degrees when it's all said and done. But yeah, since we're talking two-sided projects, let's go back to our job setup. And let's go ahead and switch it around. Let's add it. Let's make it a two-sided project. I'm going to touch off on the material surface for both sides, flip it along my y-axis, and click OK. That'll just give me my side 2. I want to delete these toolpaths here. And this one here. Yep. Bear with me. Delete that. All right. So two-sided project. So basically the quartz body of the clock is going to be a certain diameter, or, you know, a rectangle, a certain size, a certain square, right? And let's go online. And let's give old ClockKit a shout out. KLOCKIT.com. Clockit.com. And let's go to quartz movements. And they have a variety of quartz movements depending on, you know, battery operated quartz movements depending on what it is that you want. They've got it with chimes, without chimes. They have one with a speaker. That I believe they have one where you could actually record a sound, so we could have it go hoo hoo every time it hits an owl, hoo hoo, since it's an owl clock, right? That would be pretty cool. Yeah, so let's go just grab a simple quartz movement here and look at that product page. And so the shaft on the quartz movement has a certain, you know, there's only a certain thickness that it can go through. So we got to recess that quartz body into the back of the clock so that we can get a nut on those threads, right, to secure it in, and then we can get handles on the hands. Down here, it tells us that it's a 5/16 inch diameter shaft, right, 5/16. And the case size is 2 7/32 square by 5/8 inch deep. So the case size is 2 7/32 square, 2 inches and 2 7/32 by 2 7/32, and it's 5/8 inches deep. Now the shaft length, nothing on the additional information. Let's see here. Push start quartz movement, 3/16 inch maximum diameter. Usually they have the shaft length. Let's go back here and see if I missed it. The diameter is 5/16. Case size, quartz movement specifications. Let's get over here. Yeah, shaft length. So it doesn't give me the shaft length. I wish it would give me the shaft length. Well, we know it's 5/8 of an inch, and I don't think the 5/8 inch goes from top to bottom. I think that's just the case body. So Let's go to another one. Let's see if we get some more specifications on another one real quick. Let's see here. We'll go with a high torque. Okay, this one has a 3/8 inch shaft diameter. Let's see here. Again, what am I missing? Maybe this is 3/4 inch. No. It's going to be a 1/4 inch because this has a 1 inch diameter and this is a 3/4 inch body. So that would be that. So that's going to be a 1/4 inch right there. So let's go ahead and based on that information, well, it would help if I got the information. We have a size of 2 3/4 by 2 3/16. I'm just going to go square with it. So we'll go 2 3/4 by 2 3/4. Or you can make it the same size. Just make it a little bigger, right, so it fits in there. But let's go ahead and come into our size. 2.75. Let's get that centered up onto the material. So I'm just going to grab this circle right here and align to the center of that circle, just like that. And then I'm going to move this to the other side. Move to other side. On the other side, we can do our pocket cut. Now I'm going to offset this outward. Like I said, give yourself a little bit of breathing room. I'm going to offset this outward about a 1/16 of an inch all the way around. And I'm going to create a pocket cut. And the body of that is 3/4 of an inch. Now my material is going to be 3/4. I have to have it's only got a 1/4 inch shaft on it, right? So, and that shaft needs to go through so that I can screw a nut on it. That means that my front face is going to be super thin, right? And I also have to keep in mind that on the back side or the front side, I'm recessing that front side down 1/8 of an inch to get those raised numbers, right? So everything plays with everything. So if I'm recessing down 1/8 of an inch, right? My board is 3/4 of an inch thick, right? And I gotta subtract the 1/8 of an inch from that, okay, which is 0.625. And then I need to have at least 1/8 of an inch of that shaft showing through, right? So I got to pocket down to where there is 1/8 of an inch of meat left, right? It's not going to be a whole lot. So in some cases it's different and things like that. So I'm going to subtract 1/8 from that, and that's a 1/2 inch, and I'm going to calculate that toolpath. All right, let's preview that selected toolpath. And let's see here. Harvey says, didn't you make the pocket before you cut the dome? You normally would, yes. You would make the pocket before you cut the dome, or either way, however you want to run the toolpath. But no, I ran the dome first, the toolpath on that owl, so the owl had a little curvature to it, and then I pocketed everything else around it away. Did I do a profile toolpath? Oh, hold on a minute. I don't need all of these tools. Let's remove that. And a pocket toolpath cutting 1/8 inch deep. Let me look at my 3D view here. Let's reset the preview. And Let's get rid of that 16th and recalculate that toolpath. And it would help if I previewed all the toolpaths, not just the one. There we go. Holy camoly. Let's turn the color off so everything is nice and lit up here for viewing purposes. So we have this little pocket here. And hell, while we're here, on the front side, let's flip back over to the front side. Let's go ahead and do the drilling toolpath. Now the diameter of that shaft is 3/8 of an inch. 3/8 of an inch. So let me resize my center circle. 0.377. I'm going to go just a little bit bigger. No, I'm going to go 3/8. I don't want any slop. So 0.375. And I'm going to pocket that out with a 1/4 inch end mill. And I really only need to cut a 1/4 inch deep because it's been pocketed away on the rest. We can get rid of the 1/8 inch end mill and just calculate that. Okay, so now we have that hole in the center, and we have our clock mechanism. Wonderful. We can go ahead and throw in a keyhole, right? So I might want to put a keyhole right here. So I'm going to draw a circle. I'm going to go with a 3/8 inch diameter circle, and I'm going to put it right in the center for a moment. And then I'm going to move it over to the right 1 inch because I only want a 1 inch keyhole. So I'm going to move it relative to its position on the y-axis, -1, and x-axis, Laney, -1. And I'll have to recalculate all these toolpaths and fix that. When everything gets rotated 90 degrees, right? I'll recalculate all the toolpaths, but I'm going to use the gadgets. Now, if you have, I'm going to show you how to create a keyhole toolpath, whether you have desktop or pro. If you have pro, use the keyhole toolpath gadget. You just have to have a circle selected, and I'm going to go from left to right, horizontal, left to right. My slot depth is going to be a 1/4 inch. My slot length is going to be 1 inch. My entry hole diameter is 3/8 of an inch, and my neck slot diameter, the neck of my bit, is 3/16. And I'm going to select my dummy bit. You set up a dummy bit in your tool database because it doesn't care about anything else on that dummy bit. It's just going to read the feeds and speeds, right? The feeds and speeds. Everything else, it is selecting from these parameters here. So we'll calculate that. And let's go, that was wrong. Let's delete that toolpath. Delete this. Let's delete this little vector here. Actually, we'll use that vector for a minute. I want to move that back over a 1/2 inch, 0.5. Because I want the center of my keyhole slot to be at the center of my clock. All right, let's get rid of that little vector that was created by the keyhole toolpath and do that one more time. Let's see here. Keyhole gadget. All my parameters are set from my last keyhole, so I'll click OK. And now when you're previewing the toolpath, it's not going to show you the round entry hole slot, and it's not going to show you the neck. You know, it's not going to show you that undercut. You're just going to see a little dash slot in your board. But trust me, it's a keyhole. Okay, so we got a little keyhole slot for hanging the clock, and we've got our little quartz thing, whatever it may be. Now, what do we do if we don't have VCarve Pro or Aspire and we're working in desktop and we want to create a keyhole slot? Here is what you're going to do. You are going to draw a circle where you want the entry hole to be, And at the center of that circle, you're going to draw a rectangle. This rectangle is going to represent the length of the keyhole slot that you want, plus the radius of that entry hole. So I want a 1-inch cut plus the radius of my 3/8 inch diameter hole, which is 3/16. So I'm going to have 1 3/16 inch rectangle. 1.1875, and I want to push it over to the right. Let's try that again. 1.1875. Okay, so want to go that big, and that'll be fine. 1.25. There we go. 1 1/8 will be fine. That's what I want. Now the height, this is the important part. The height of this rectangle is going to be 0.001 inches high. So it looks like almost a line on your board unless we zoom in really, really far and you can see the rectangle. Okay? So 0.001. Now, on the left side of this rectangle over here, and it should be a rectangle, not rounded. Let me go into my rectangle tool and fix that with square corners. Wonderful. In node editing, we're going to delete the span on the left side. So we have a start point. It's going to come down and cut at that start point. It's going to come in, raise up, come back, and cut. Now we want this start point to be at the center of our circle. So let's go ahead and move it up to the center of our circle. Actually, that was wrong, Laney. Let's get out of node editing mode. That would help. Let's move it up to the center of our circle. There we go. And what's going to happen is it's going to plunge in. It's going to travel. It's just going to move over that 1/1000th of an inch, travel back, and then raise up out of the same hole that it came in. So again, this would be, in this case, it would be a profile toolpath cutting on the line. And my depth is going to be 1/4 of an inch deep. I'm going to use my keyhole bit, so I'm going to set the toolpath up with my dummy bit. Let me get down to my dummy bits. Where are my dummy bits at? Oh, it won't show me the dummy bits unless I'm missing them. So I'm just going to use my 1/4 inch end mill because it's the same numbers and everything that I want. Because again, feeds and speeds is all that it's going to be caring about, because in our actual router is going to be the keyhole bit, right? I want this to be done in one pass, so I'm going to edit my passes and it's going to do it in one pass. So it's going to come down, cut across, move over a little bit, come back, and come out of that same hole. And the hole is going to be slightly bigger by 1/1000th of an inch, but you'll never see it. And we're going to calculate that toolpath, right? And so if I were to reset the preview and preview that visible toolpath, we're going to get that same visual of that slot, right? Because it's not going to show us the keyhole slot, the undercut, okay? That is how you would create a keyhole toolpath in Vectric VCarve desktop, since you don't have access to the keyhole gadget, okay? So 1/1000th, 0.001, and then you remove that front end. That way you have a start node where it's going to cut on the line, move over, and it's going to come back to the end of the line and raise up right out of that same hole. Okay? Very cool. And whatever your length is how long your slot's going to be, right? Your keyhole slot. Okay. All right. And let's see here. I think y'all were correcting me on um, I think y'all were just correcting me on my circumference and my diameter and everything. Now, you guys are talking about what are the two numbers of pi and this and that and everything. Suicide at all times. Let's do it over. Which window can y'all see better? Here, let's do this. I'm going to drag this into the middle of the screen and I'm going to size it up. And okay, I'm just going to use the set size for a minute. Just any one of these entry boxes, these little boxes are like miniature calculators, right? So if I want to know the pi of something or what have you, I can go 4 times p in that box and hit equals, and that'll tell me what their circumference is, right? If I come in here and hit the letter P and just hit equals, let's hit the letter P, equals 3.141539, blah, 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 blah. So it'll give me pi. The letter P in their software is pi. So I can go, if I want to know the circumference of 3 times P equals, right? To get that circumference and stuff. So, and everything. If I want to know 0.125 times P equals, it's 0.392, blah, 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 blah. That's the circumference of an 1/8 inch circle. So use letter P. Just like in the software, the letter T shows you the thickness of the material, as well as the letter Z. So if I hit Z equals 0.75. So Z and T, thickness or the Z height, right? So those numbers. And so if I was doing a profile cut or something, and let's say that I wanted to, I've got a 3/4 inch board and I want to leave 3/16, I could type in Z minus 0.1875 equals, and that'll give me my cut depth, right? 0.5625, right? So, or I could do T minus 3/16. Either one of those two will give me the right height for my thickness. P for pi and things like that. So these little boxes, anywhere that you enter in a value, they're like little calculators. You can add, subtract, multiply, divide, and you can do fraction to decimal conversion. Okay? Cool. And you probably knew that already. Y'all might have just been having a conversation about pi, but for those of you that didn't, I wanted to show that. Okay. Robert Casa, how would you create a curved keyhole toolpath with entry holes on both ends? With entry holes on both ends. So you want to enter in, create a curved keyhole toolpath, and then come out of the other end. So you have basically entry holes on both ends. Number one, look at your keyhole bit and make sure that the cutter is on top of the cutter head, so that when you come in and cut, when it raises up, it'll cut out instead of tear out. That is one way you could do it, but I wouldn't recommend that. Here's how I would create a curved keyhole toolpath with an entry hole at both ends. Here we go. So let's go ahead and we'll create our, I'm just going to use circles just for the reference of the entry and exit. So I'll go with a 3/8 inch circle here. And let's just take this, Control C, Control V to copy and paste. And then I'm going to move that pasted copy to the right. Let's go 1 1/4 inches. So I'm going to go 1.25 and click apply. There we go. Nice, sweet. All right. Now I'm going to come in and create an arc. Let's snap to the center of this circle, snap to the center of this circle. That's not an arc tool, Laney. Let's undo that. Why am I not grabbing my right tools today? Let's go from here to here. Create the arc in whatever fashion that you want it to, whatever arc you want it to be. All right, coolio. And we're going to offset that arc inward. Offset inward 0.001 and create that offset. We're going to zoom in. We're going to select these 2 points right here, and we're going to join with a straight line. That was... Bear with me a second here. Select my 2 arcs. Join with a straight line. There we go. And why is my join with a straight line looking so weird? That's okay, because it should separate by that thousandths of an inch when it gets to here. Great. That's fine. I'll work with that. All right. So we are going to, if we go into node editing mode, we have a start point and an end point here, right? Start point and end point here. And what we're going to do is I'm going to take a line at the center of my arc, and I'm going to draw a line here. Boom. And I'm going to take that vector and I'm going to go into my mirror tool and I'm going to select that vector, select this line, and I'm going to flip it about that line, right? So I have 2 separate vectors overlapping each other with 2 separate start and end points on each end. Rightio. All right, we're going to create a profile toolpath cutting a 1/4 inch deep. It's 2 separate toolpaths, ladies and gentlemen. So we'll start with this one and we will calculate that toolpath. And so this tool, the first toolpath will come in and it will enter in on one side, cut the arc, come back and come out of that same hole. And then we're going to duplicate that toolpath, create a second one doing the same thing. However, we're going to recalculate that for this vector, calculate. And when we save those 2 toolpaths, we will save them as one file. So it'll come in, cut, and come back out of the same hole, move over, come in, cut, and come back out of that same hole. Okay. Right? That's how you would do an arced keyhole with entry holes at both ends. Cool. All right. So Robert Casa, hopefully that answered your question. Right? Coolio. So just like that. All right, let's get rid of a lot of these toolpaths. We'll get rid of that one, and this one. Okay, so on my back side, I just have my keyhole toolpath and I have my little pocket cut there. On the front side, I should still have, let me make sure that I want to do the raised numbers, so I'm going to get rid of this toolpath. And if I preview this, let me make sure that everything is still intact, except for this pocket. What's that pocket? Oh, yeah, that's that one. So that will move that up. Boom. Boom. There we go. Move it up one more. All right, so I've got a 1/4 inch bit that's going to do some 1/4 inch work. Preview the visible toolpath. If these are still calculated correctly, I have to go back and think that. Yeah. Okay. I need to clean out. I don't want this thing raised up here. I need to clean that up. Let's see. I have an 1/8 inch bit that will clean up a little bit in the numbers, and then I have a V bit that will do the VCarve. around the numbers and letters and a cute little owl. And then I have a profile cut, cutting the outside out. Coolio. Now, this little divot right here, that little divot, that's because that divot is there is because in my VCarve toolpath, when I selected all the vectors, that little circle was selected. I want to turn that off. I don't want that in the VCarve toolpath. I only want that for my little pocket toolpath that's going to cut that hole out. I don't want that little mountain there and everything. So I just want that in the VCarve toolpath. So if we preview those toolpaths again, that little island in the middle will be gone. All right, let's flip this over. Or actually, let's just preview all sides. I will make these vectors available to you. It'll be a 16-inch diameter clock. I'll make these vectors available to you in case you ever want to make an owl clock, right? It's something cute and fun. But it just gives you a general idea, right? This animal or this up here on the top of the clock, or even around the outside of the clock, it could have been anything, right? It could be anything that we want it to be. We just, you need to make the appropriate vectors for your boundary cut, of course, cutting the shape out. But you make the appropriate vectors to create whatever illusion or look that you want. In my case, we had the vectors of the owl, okay? That's just doing the VCarve of the cute owl. Then we have an additional vector around the perimeter so that it creates kind of this channel around the clock and the owl to give it just a little bit of almost like a little bit of a raised effect. Just a little bit, so it's not so just flat, right? And when we did that perimeter, we had to add an additional vector around just the owl so that the owl still carves the way we want it to. And then, of course, we have our final profile cut, cutting everything out. So whatever your object is, whatever it may be, just make sure you have the appropriate boundaries or vectors to get the look that you want. Whether that look is on top of the clock or inside the clock, because we could, like I said, I could do some text in here. We could do another little design. We could have, this owl sitting here and, hey, let's do something fun. Hold on a second. Let's do something fun. Let's go on to online. Let's go mouse vector. And let's go in here. Let's go mouse with cheese vector. Let's go to images. And let's grab, let's go to tools and filter out a lot of this stuff. I want large images. Wonderful. And let's grab one that has a good amount of detail. Bear with me a second. Did I spell mouse right? M-O-U-S-E. There we go. Let's grab this here. He's a furry mouse, but that's okay. It'll work. Save image as. We'll call this mouse. Let's close out of that. Let's import that image. Oh, he's a big one. He's bigger than the owl. Let's go ahead and let's move him off to the side so y'all can see what's happening here. Let's go into the Trace Bitmap tool. I'm going to draw a box around the mouse and the cheese. And turn the fading off so y'all can see what's happening. I'm going to slide this forward to here and preview, apply and close. I'd probably find a mouse with a little bit wider vectors around it, but that's okay. Let's size him down. Let's throw him on the clock. He could be right in the middle, right? That owl looking for some lunch. All right, let's go with a... I want a little bit wider border lines around him, so I'm going to ungroup him. And I'm going to take his outside boundary and offset it outward just a little bit. I'm going to offset it outward by another, I don't know, we'll go just 20 thousandths. No, that's too small. Outward, by the way. Let's go a 16th. Yeah, that'll be fine. And let's create that VCarve toolpath. Now this VCarve toolpath is going to be down in this pocket, so I need to start at my 1/8 of an inch because that's how my pocket is. And I'm going to go no flat depth on this and no tools because it doesn't require it. Let's calculate that. And again, I've got some overlapping lines. It's most likely a trace, but heck, while we're here and we're learning things, it's going to be my 2 circles right there are overlapping because that guy, I don't even need to do that anymore because I know what it is. Let's calculate that again without that center circle. Oh, no, it wasn't that. Let's find out what it was. Again, those little pixels. Those pixels are troublemakers. Let's go ahead and delete that one. And there's another one over here on the other side. And this one's not a pixel overlap. It's an intersection right there. Let's close this. And if I go into node editing mode, I had a line intersecting. Let me show you. Let me pull this out. You see there was a node right there, and if I undo that, they were on top of each other. That's kind of considered a 0 length span. And in the vector validator, that 0 length span, there's a button right here that you can click, and it'll get rid of that. Okay, cool. All right, let's go back and select him again. Not my center circle, and hit calculate. Oh, I do have to put a flat depth on him because of the holes in the cheese. Oh, I know why. When I'm an idiot. Hold on. Let me delete this outer perimeter. Let me select that outer perimeter again. When I do the offset, I want to delete the original. I just want those lines a little wider. There we go. I don't want that original. So one more time, let's select that and calculate. All right, let's go ahead and preview the visible toolpath. There we go. And let's add a little bit of color to this guy here. Let's use toolpath colors to separate this out a bit. I'll go with, we'll just go with black so you can see that. On the owl, let me just create a toolpath just for the owl vectors that's separate from all my others. It's for color purposes only, ladies and gentlemen. So let me select my owl and let me turn off this outside boundary right here. And I'm creating a VCarve toolpath. Starting at 0, no flat depth. Just for the purpose of coloring. And I'm just going to put owl color. Right? So let's calculate that. All right. On that toolpath, let's give it a little bit of color. I don't know, we'll go black with him too. What did I mess up on his color? Hold on a minute. Let me see what I messed up on the owl here. I didn't mess nothing up. Calculate that toolpath. Yeah, that's him. That's what I thought. I was wondering. I was like, wait a minute now. Let's get our mouse on there. All right, and let's go ahead and preview the rest of the toolpaths. And so you could have some fun with it, right? Let that finish carving out. All right, whatever you want it to be. All right, let's see here. Is a keyhole cutter made with a cutter, end mill shaft, or with a larger lower cutting disc? So there, on most keyhole bits, Suicide at All Times, most keyhole bits have a cutter on the shaft, the shank, unless it's a slot cutting bit. A slot cutting bit does not have a cutter on the shaft. So let's go keyhole router bit. And let's zoom in here. So on a keyhole router bit, usually there's a cutter on the shaft there, so it creates that neck cut as well. But on a slot cutter router bit, let me find one that is a true slot cutter there. Does not have a cutter on there, so you would actually have to use an end mill to clear out the slot, and then it cleans up the waste and creates a T-slot. So it's a T-slot cutter. So those don't have it, but a keyhole cutter has a cutter on the neck, if that's what you were asking. I think that's, is a keyhole cutter made with a cutter, end mill, shaft with a larger and lower cutting disc? So let's go back to the keyhole bits. And on the keyhole bits, we'll use that one as an example. You have a larger disc that has a cutter for plunging, and then it cuts to a certain depth on the neck. In this case, for this particular bit here, it's going to be 1/4 inch. So you have that cutter there. And so when it plunges down, it's able to cut the slot, come back and cut up. And that way it creates those overhangs so you can hang the picture on a screw and it won't fall off, right? I think you were asking that, but I'm not sure. Let me know. Phil Reaper says, how would you keep the owl eyes? So let's go back. Let's get out of here. The owl eyes are there. So when we colored in this particular owl, if we look at the actual reference image, which I deleted, let me bring him in again. He has those cool black owl eyes, right? So those cute owl eyes. So all the black area is the area that's getting carved. All the white areas are your wood, right? So when we preview here and we look at that, all the black areas are the areas that are getting carved. So he has those big, beautiful black eyes and everything. And all the white areas are the wood, whatever that wood may be. You know, right? This could be an oak clock or what have you, whatever you would want it to be, right? So his owl eyes are kept in that sense. Phil. Let's see here. Off topic question. Anyone know what metals will fuse with brass? Oh, okay, that's totally off topic. I'm not going to answer that one. I don't know. That was what I was asking. Great, Suicide. And you have an 1/8 inch thickness in the works pocket area. Did it cut through in the mouse eyes and the cheese? So let's turn off the color and let's view all tool pass, right? Because this is the mouse is only cutting 0.1733 inches deep. So the question was, we only have 1/8 of an inch in this area here because of the clock body on the back side. Let's view those backside tool pass. And let's flip back over. And no, there's no cut through there. It's probably super thin, but no, there's still meat there. You know. Let me turn up the resolution. Oh, it already is up. Okay. But no, there's no cut there. Oh, but you would want to be careful for that, right? That would make sense to make sure that whatever you do, that you're not cutting too deep and everything. And also make sure that your cutouts, that you can't just pop those parts right out because there's only a splinter of wood left and things like that. But in this case, it didn't affect it. But if it did, I would just move the mouse over, you know, somewhere, or I would probably have a scurrying mouse or something. I'd find a vector of a mouse kind of running, you know, or something like a Tom and Jerry type mouse, whatever the case may be, if I was doing that. But that's kind of cruel because that mouse is actually food, right? The owl's looking down at him and eating them. So that wouldn't be a nice clock to have on the wall. But for the cutesy effect and all that stuff, you know, it is what it is, right? And everything. So just a very simple basics. I don't want to go too far into this, guys. This is going to be a low class. We're going to end it here. But the main thing I wanted to show you is how to create your clock numbers with using the circular array tool and rotating those dashes by that 30-degree increment to get those numbers laid out correctly and all. And also, if we were going to do something with this clock, whether it be inside the clock like the mouse or on the outside of the clock like the owl, ways that we would approach that, right? So when we set the owl on the top of the bezel, we had to remove the owl's tail. So we created a slight offset and we did a trim tool to retrim those vectors, clearing inside that circle. And then we got rid of that offset. And then I wanted a little bit of a, let me do this real quick. It might make it easier on y'all's eyes. Let me go into my options here. Let me change my colors from black to, let me just lighten them up a bit. Okay, just kind of lighten that up a bit so we can see the clock a little bit better. And let me turn off, we'll go light follows you viewer. All right, that's fine. But I wanted that little raised bezel around the clock. So we created another offset to create this little channel going around the outer clock and around the outer owl, just to give it a little bit of dimension, right? Just to give it just some kind of dimension in everything. And then, of course, finally, we had another offset creating that profile. And this would apply for any type of wall clock or whatever, any type of clock you want to do to create some different things. Now, I want to end this by just showing off a little bit of a clock that I did for the Digital Woodcarver owners group. And it was a 3-dimensional model clock. Let's go in here and come in here. And this clock, let me zoom in. Ooh. This clock has a, it uses a clock insert, not a quartz movement, just an insert that you cut a 3 1/4 inch diameter hole and it pops into the back, and it's got a 7 7/8 inch face. But this model, let me close out of that and go to here. This is the model without the, that's the clock insert. That's the model. That's the clock insert. That's the model. But you know, this is kind of a wall hanging clock. It looks like a mantle clock, and if it's made thick enough, it can stand up on its own, but it's typically a wall hanging clock. But that was done in Aspire, but you know, just some, you know, that's what got me into the clock mood and everything. And all was designing this clock for the to send out to the customers that subscribe to training and all. They got 2 models this month. They got the clock, and then they got this fire department model that are made for them and stuff. And every month they get 2 free projects sent to them every month, right? So if you're interested in Spindle TV training or training in your Vectric software and you want to subscribe, you get 2 free projects sent to you every month and all that fun stuff. But as far as this clock is concerned, these vectors as well as the grapevine, those are free. Those are going to be, the files will be in the description of the class. And I'm just going to send you the vectors, the DXF vectors on this. And then, of course, the model will be the download for the other one, that Vine model we did last week. But just something to play with and stuff, just to give you some general idea, just to have fun with. But you can delete whatever vectors you don't want and all that happy jazz. Because many of you may be on 10.5. A lot of you may not be on 10.5. So we'll just download the DXF files and you can play with them there and stuff. And it's a very simple VCarve toolpath with a 1/8 inch flat depth. Choose your bits. That'll do the majority of the clock. There is a small pocket that cuts out the center of the hole. And then there is a VCarve for the little mouse, if you want the mouse, and then the profile cut to cut out. The owl one here, that's just for color purposes. That wouldn't apply. But fun stuff. Hopefully you got something out of this short little lesson, and it is going to be short. This is going to be our shortest one so far, 2 hours in. But I don't want to harp on this. It's pretty straightforward. But just use your imagination now that you know how to lay out the clock and stuff, and anything could be across the top. Hell, you could be, you know, Ford, Mustang, or it could be, you know, Dad's garage, or it could be text. It could be whatever you wanted, right? This clock could do anything that you want with it. Now you know how to lay it out and get some cool little effects and things like that, right? So, all right, everybody. Hopefully you got something out of tonight's class and you found it useful. Thanks for joining me. Thanks for hanging out. As always, I appreciate your support. This time I do mean it. Give me just about an hour. And the vector download will be in the description of this video for this owl clock layout. The vectors will be, and the model Vine model, that grapevine model we made, will be in the other video description. Those 2 will be ready for download in, give me just about 45 minutes to an hour once I sign off, and they'll be there. All right, everybody. Thanks. Clock kit. So KL, let me put it in the chat here real quick. KLOCKIT.com. Clockit.com. So KLOCKIT.com. And I put it in the chat room there. All right. Everybody, thanks, everybody. I really appreciate you. Every week I do appreciate you. If you look forward to seeing you next Tuesday. And until next time, have a good night. Enjoy the rest of your week. See ya.